Welcome in GeoVision with JD. In the earliest days of human civilization, the Earth was widely assumed to be flat. This view was intuitive. After all, the ground beneath our feet appears flat, and the horizon seems to stretch endlessly in all directions. Ancient cultures, from the Babylonians to the early Egyptians, depicted the world as a flat disk or rectangle, floating on or surrounded by water. The first seeds of doubt about a flat Earth were sown in ancient Greece. In the 6th century BCE, the philosopher Pythagoras suggested that the Earth might be a sphere. His reasoning was philosophical rather than empirical. He believed that the sphere was the most perfect shape, and since the heavens were spherical, the Earth should be as well. Aristotle, in the 4th century BCE, provided more concrete evidence. He observed that during a lunar eclipse, the Earth's shadow on the moon was always round, something that would only occur if the Earth were spherical. He also noted that travelers moving southward saw stars previously hidden below the horizon, which suggested a curved surface. The first known scientific measurement of Earth's circumference was made by Eratosthenes in the 3rd century BCE. Using simple geometry and the angles of shadows cast by the sun at different locations, he calculated the Earth's circumference with remarkable accuracy, approximately 39,375 kilometers, very close to the modern value. The idea of a round Earth spread through the Hellenistic world and later the Roman Empire, becoming widely accepted among educated people. The spherical Earth was depicted in globes, and scholars like Ptolemy in the 2nd century CE further refined the understanding of Earth's size and shape. During the Middle Ages, the knowledge of a spherical Earth was preserved by Islamic scholars and later reintroduced to Europe. While some myths suggest that medieval people believed in a flat Earth, most educated Europeans knew the Earth was round, as evidenced by the writings of scholars like Thomas Aquinas and the spherical depictions in medieval maps. The age of exploration provided practical confirmation of Earth's roundness. Explorers like Ferdinand Magellan embarked on voyages that eventually circumnavigated the globe, proving conclusively that the Earth is not only round but can be traveled around. The final undeniable proof came in the 20th century with the advent of space travel. Photographs of Earth taken from space, such as the famous blue marble image captured by the Apollo 17 crew in 1972, show our planet as it truly is, a stunning blue and white sphere floating in the void of space. The concept of a round Earth is not just a scientific fact, it is a testament to humanity's ability to question, observe, and understand the world. From ancient philosophers to modern astronauts, our journey to understanding the true shape of our planet has been one of curiosity, discovery, and awe. Key evidence supporting a round Earth. Lunar eclipses. During a lunar eclipse, the Earth passes between the sun and the moon, casting a shadow on the moon. The shadow is always round, indicating that the Earth is spherical. If the Earth were flat, the shadow would be elongated or otherwise distorted. Observations from different locations. Ships disappearing over the horizon. As ships sail away, they seem to sink into the ocean from the bottom up, which is consistent with a curved surface. If the Earth were flat, ships would simply become smaller as they moved away. Differences in star constellations. Different constellations are visible from different latitudes on Earth. For example, the Southern Cross constellation is visible only from the southern hemisphere. This would not be possible if the Earth were flat. The Coriolis effect. The Coriolis effect describes how moving objects are deflected to the right in the northern hemisphere and to the left in the southern hemisphere due to Earth's rotation. This effect is consistent with a rotating spherical Earth. On a flat Earth, the Coriolis effect would manifest differently or not at all. The observed patterns of deflection align with Earth's curvature and rotation. Photographic evidence. Since the advent of space travel, numerous photographs have been taken of Earth from space, showing it as a round planet. One of the most famous images is the blue marble photograph taken by the Apollo 17 crew in 1972. Space photographs consistently depict Earth as a sphere. These images come from various space missions and countries, providing independent confirmation of Earth's shape. The technology to fake these images globally is implausible. Gravity. Gravity pulls objects towards the center of mass. On a large scale, this force causes the Earth to take on a roughly spherical shape as it minimizes potential energy. A flat Earth would have a very different gravitational pull, leading to all sorts of inconsistencies with observed phenomena. However, even today, some people still believe that the Earth is flat. Let's take a look at their most common arguments. The phenomenon of belief in a flat Earth. Despite overwhelming scientific evidence that the Earth is round, there is still a group of people who believe that the Earth is flat. This belief is often associated with a distrust of scientific institutions and a deep skepticism towards official information. Let's now take a look at the most common arguments used by flat Earth proponents. The first argument often cited by flat Earth proponents is the flatness of the horizon. They claim that when we look at the horizon, we see a straight line, not a curve. Facts. The Earth's curvature on the horizon is very subtle and practically imperceptible to the naked eye. The curvature becomes noticeable only at great distances or from high altitudes. Visibility over long distances. Another argument is that over long distances, such as across the ocean, the Earth's curvature should be visible, but distant objects like mountains or buildings are reportedly still fully visible. Facts. Atmospheric refraction can cause distant objects to appear as though they are hovering above the horizon, which might falsely suggest that the Earth is flat. Distrust in scientific and government institutions. Many flat Earth proponents distrust scientific and government institutions. They argue that the shape of the Earth is part of a vast conspiracy aimed at keeping humanity in the dark. Facts. This argument is based on conspiracy theories and ignores independent evidence provided by scientists, astronauts, and technicians around the world. Distrust of space photography. Another common argument is that photographs of the Earth taken from space are fake and manipulated to maintain the illusion of a round Earth. Facts. Photographs of Earth come from many different space agencies from various countries. Faking them would require a massive global conspiracy, which is extremely unlikely. Biblical and religious texts. Some flat Earth proponents refer to a literal interpretation of biblical or other religious texts, which they believe describe the Earth as flat. Facts. Many believers and theologians interpret these texts symbolically and do not see them as a literal description of the world. Scientific knowledge should not be confused with religious metaphors. The persistence of myths. The belief in a flat Earth is a fascinating example of how myths and conspiracy theories can survive despite scientific evidence. Whatever the motivation, it is important to remember that science and evidence stand on solid foundations, and our goal should always be to seek the truth. Which other arguments there might be? Let me know in the comments what your perspective is, and if there's anyone here who believes the Earth is flat, I'd appreciate hearing your opinions and the reasons that led you to believe in this theory. I also encourage a respectful and open discussion in the comments. Thank you for watching. If you liked this video, subscribe this channel and don't forget to put your thumb up. And the most important, explore.